In Chapter 2, we're going to look at how Egyptians performed their multiplication and division. And also, we're going to look at how Egyptians solved the algebraic equations by the rule of false position. First, let's look at the multiplications. This is example on page 52 in the textbook. Find out the product of 26 and 33. The first row here, 133, and the second row means 2 33s, which is 66, and third row, 433 is 132, and 833 is 264, 16 33s is 528. So we can find out today, of course we can find out 2 33s by multiplying 33 and 2, and 4 33s by multiplying 33 and 4, and similarly for the others. But what the Egyptians did was to double the number again. So for example, if we want to find 2 33s, we can add 33 and 33, and we get 66. In order to find 4 33s, of course we can multiply 30. We can add 33 and 33 and 33 and 33 4 times, but we can also add 66 and 66 to get 4 33s. And similarly, we add 132 and 132 to get 8 33s, and 264 and 264 to get 16 33s. And so we have the multiples of 33, and we can look at the first column, because what we need is 26 33s. So we try to make a 26, and we pick those numbers 16, 8, and 2, and add them together, which is exactly 26. And we find out their corresponding multiples. So 2 33 is 66, 8 33 is 264, and 16 33 is 528. And we add these numbers together to get 858. That's exactly 26 33s. So that gives us the answer. So you can see the Egyptians used this doubling process to avoid multiplication tables. And similarly, they can use the doubling process to find the quotient and remainder. And this example is on page 53. So this time they doubled the divisor 26 by adding itself. 26 and plus 26 is 52, and double 52 by adding 52 and 52, and adding 104 and 104 to get 826, and they added 208 and 208 to get 1626. Okay, so because the dividend is 753, so we try to find out, we try to pick the numbers from the second column and try to make 753, or a number which is very close to 753. So we picked 416, 208, 104, and we add them together to get 728. And we cannot pick another number, another multiple of 26, because even the least 126 plus 728 will be bigger than 753. So the most multiples of 26 we can get is 728, which corresponds to 2826. So we get our quotient 28, And we check the difference between 753 and 728. That is 225, and that's what's left, and that is the remainder. Okay, so 753 contains at most 28 26, and the left will be 25, and that is the remainder. Okay, so that's the first type of problems, multiplication and the division of Egyptians. And the second type of problem, how did they solve an algebraic equation? Today, we're going to we're going to isolate x to get our x, because right now we have all those rules. For example, we can multiply or divide the same number both sides. For example, we can multiply by 7 both sides, and we can add a same number or divide by the same number, or subtract the same number, so we can isolate x. But at that time, the Egyptians did not have any rules like we had today. And so what they did was to pick an arbitrary number 7 and plug it into the left side and check if we could get a 24. And so we plug it in to the left and evaluate it. 7 plus 7 plus 7 over 4 is 8. And we compare the answer we get with 24, and that's what we want. And so we found out we need to multiply our answer by 3. And notice this is a linear equation. Every x has a degree 1. So if we multiply x by 3, and then the first term x is multiplied is tripled, and the second term x over 7 is also tripled, so like we see here. So of course the right side is also tripled. Okay, so that means our answer should be 7 times 3, which is 21. So the idea is to guess the answer first and make corrections for the answer. Okay, that's a linear equation. Now let's look at a quadratic equation. So here the degrees of x and y are 2, and this is actually a system of equations. We start with the second. Today our method will be substitution, because we can replace x with 3y over 4 in the first equation to get rid of our x, and we get a quadratic equation, use the quadratic formula or factoring to get our y, and then go back to the second equation to get x. And at that time they were using rule of fourth position. So like we did before, first they try to pick two arbitrary numbers. So we look at the second equation. We can pick a number for y first, because the denominator is 4, so we can pick 4 to get rid of the denominator, and the corresponding x will be 3. Now we evaluate the left side. So plug them both into the left side. We get 3 squared plus 4 squared is 25, and compare our answer and the original problem. We should multiply 25 by 4. But does this mean we just need to multiply 3 and 4 by 4? The answer is no, because here the problem has degree 2. And notice, if we double our numbers 3 and 4, then and plug it in, because of the square, so we distribute the power to each base. So we get 3 squared times 2 squared, which is 4, plus 4 squared times 2 squared, which is also 4. And then you will notice if we double x and y, actually the left side is multiplied by 4. So that's exactly what we want. If the left side is multiplied by 4 and the right side 25 is also multiplied by 4, so we get our answer 100. And that means how to make corrections to our numbers 3 and 4 is to double these two numbers. So we double 3 to get our x and double 4 to get our y. And we can check our answer. 6 squared plus 8 squared is exactly 100. Okay, so the rule of fourth position is to pick a few numbers and try to plug it in to check what corrections should we make. Alright, so these are the problems of chapter 2.